This is 3.2 logarithmic functions. My f of x equals 2 to the x. We did this on our last lesson. Okay. So our table was -1, 0, and 1. And my y values were 1/2, 1, 2. So if I plot those, -1, 1/2, 0, 1, 1, 2. Here is my exponential graph, my asymptote. Your domain, in this case, was all reals. Range was 0 to infinity. My asymptote is y equals 0. And our end behavior, my limit as x approaches negative infinity, that is my limit on the left. If you notice, it's getting closer and closer and closer to 0. So my limit is getting closer to 0. Then on the right, my limit as x approaches infinity, I'm going to the right, of f of x is positive, infinity. Okay, so that is what we did in 3.1. So now we're going to talk about exponentials, which are inverses of logarithms. So an inverse basically means that you're switching your x and your y coordinate. So we're going to basically keep everything the same, except we're going to take all of our x values here and put them in the y column. We're going to take all of our y values here and put them in the x column. So we're going to switch them. That's what gives you an inverse. So then I'm going to plot them, 1/2, -1, 1, 0, 2, 1. And this is what my graph looks like with a vertical asymptote. And so if I look at my domain and my range, my domain now is 0 to infinity. My range is -infinity to infinity. My asymptote has switched, and now instead of it being a y equals, it's an x equals. So you'll notice a couple things before I start talking about end behavior. My domain of my exponential is the same as my range of my logarithmic. My range of my exponential is the same as my domain of my logarithmic. They're inverses of each other. Okay? So basically they're going to switch. So if I ever give you a domain and range of an exponential, hint, 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 and I ask you what the domain and the range is of its inverse, all you have to do is switch them. If I give you equation of an asymptote on an exponential function and I ask what its asymptote is for its inverse, all you do is basically keep the same thing. It's just y equals 0 to x equals 0. So those also are both still the same number, but they switch from x to y. Now we're going to talk about end behavior. So for end behavior, this becomes a little trickier because right here, okay, our x's are not going towards negative infinity. You notice we're not coming over here. You have a barrier here with your asymptote. So my x's are actually getting closer to 0 on the right-hand side. So now when we do our limit, this is something new. We're doing limit. This is all, oops, let me erase this. Let me mark this off. Okay. Okay. Let me go back to the purple. Okay, so my limit right here is not going towards, like this one, when we did left end behavior was limit as x approaches negative infinity. This one, the limit is approaching 0 from the right. So my limit as x approaches 0, and the way that we tell it from the right is we do a plus. If I had my graph over here, you would tell me that my limit was approaching x from the left. So we're not doing positive or negative infinity anymore for logarithms. It still stays the same for exponential, But on logarithms, you're going to have to be a little careful. This graph is approaching 0. It's not going to cross through 0. Remember, it's not going to cross through a vertical asymptote. And even here on exponentials, it won't cross through a horizontal. So it's approaching 0 from the right. And that is going to, basically my y's are getting smaller and smaller and smaller. So it's going to equal negative infinity. When we want to do limits on my right-hand behavior, my limit, this one is still the same. My x's are getting bigger and bigger and bigger. There's no barriers to it. So as my limit approaches infinity of f of x, my x's are getting bigger, so it's positive infinity. So you're going to have to be careful on logarithms. One of these is probably going to be a 0 from the right, a 0 from the left, depending on which way you're coming from. Next, we're going to look at your special functions. E to the x is your natural base. It's e to the x, e is 2.7, is a common number found in nature. And then log base e of x, or natural log of x, is called your common logarithm. Okay, so if we graph e to the x, we did this in 3.1, negative 1, 0, 1. So 0.37, 1, 2.7. This is what you're supposed to have memorized. Negative 1.37, 0, 1, 1, 2.7. Graph it, asymptote. So now we're going to do our inverse. These are inverses of each other. So log base e means ln. They've just come up with a common term for it. Or natural log, not ln, natural log, called a common logarithm. So for your logarithm, we're going to switch them. Negative 1, 0, and 1 is going to go on the right. 0.37, 1, 2.7 on the left. So 0.37, negative 1, 1, 0, 2.71, and asymptote. Okay, this is going to be the same as on our other screen. My domain, 0 to infinity, range, negative infinity to infinity. My asymptote, x equals 0. If I want to look at my end behavior, this one is coming from towards 0 from the right. So this is my limit as x approaches 0 from the right. This is my left end behavior, and it's going towards negative infinity. If I want to do my right end behavior, that's my limit as x approaches infinity, and it's getting bigger. So that's basically the same as the last screen. The only difference is you have a specific number down here for these. Okay, so let's graph one with everything in it. The first thing that you have to remember is you need to factor first. So I need to factor out a negative in order to do my transformations. So I need to take a negative out of this part right here, because in order to figure out if I'm going right or left, it has to be x minus something or x plus something. I can't do that if there's a negative there. So you have to factor the negative out. And if you don't, your graph is going to be messed up. And this is a strong hint. I would make sure that you can do one of these. Hint, hint, hint. Okay. So my negative, this is a horizontal reflection. Then this plus 3 moves left 3, and let's do purple. My 2 moves up 2. So we're going to start with our parent, which is log base 4 of x. So negative 1, 0, and 1 on the right. Since this is a base of 4, you're going to use 4. 1/4, 1, 4. So if I plot my parent, I'm going to start with red. I'll do red as my parent. That is 1/4, negative 1, 1, 0, 4, 1. I'm going to just kind of lightly do it. This is my original graph. Okay. And then we're going to move everything. So 1/4, let me make it dark. 1, 4. Okay. So next, I'm going to do my horizontal reflection. And so that I'm going to move horizontally. Or reflected horizontally, sorry, not move. So it's moved to there. Now I'm going to do my left 3. I'm going to do my left 3 and up 2 all at the same time. So left 3, and I might go off my graph a little bit. 1, 2, 3, up 2. Left 3, up 2. Left 3, up 2. So my graph is right there. You may have noticed that my equation, my asymptote, was originally right here at x equals 0. When I did the reflection, it stayed at 0. But when I moved left 3, that's going to move my asymptote over to -3. So now if I want to do my, hold on a second, let's leave some space here. Okay. So if I want to do my domain, that's going from -infinity to -3. Okay. And then my range is all reals. This is my final graph. Okay. And then, oops, my asymptote is now at x equals -3. And now for my end behavior. This time, looking at my right end behavior, this x value is getting closer and closer to -3. But if you notice, there's no blue values over here. So my graph is approaching 3, but this time it's approaching it from the left. So let me change colors. Let's do orange. Okay. So my right end behavior right here is my limit as x approaches. It's approaching -3 from the left. This little negative up here tells me that I'm approaching -3 from the left. And that is getting, my y values are getting smaller and smaller and smaller and smaller. So it's going towards -infinity. If I want to do, let's do yellow. My left end behavior, that's my limit as x approaches -infinity of f of x. And that's going to get bigger and bigger. It's going to go towards +infinity. So you need to be careful when you're over on the left-hand side and you have a vertical asymptote. You're going to approach the asymptote and not for your x values. You're approaching positive or a negative number and not an infinity.